Welcome to video 10b. This is surface area of prisms and cylinders. So just a reminder, you guys, about surface area. It's the total area of all of the faces and all of the curved surfaces of a three-dimensional figure. Okay. The lateral area that we're going to be talking about is basically the area of all the faces, the ones that are not the bases. So that's what lateral area is going to be referring to when you see that term. So let's start by trying to figure out if we can develop a formula for this surface area here. In this particular picture, we have a right prism that is a triangular prism. So the face that I just outlined, I hope you can see, corresponds to that middle rectangular face on the net that's right next to it. And so we're going to fill in the dimensions of base times the height for that middle rectangle. Then this back face, back left if you will, face is going to be that left-hand flap that you see there. And its length is A. And so then of course on the right-hand face, we've got a length of C on that side of the triangle. And so let's answer these questions. In the net, what type of figure is formed by the lateral faces of the prism? Those are the ones in the dark gray that you can see there. And if we put those faces together, since they're three side-by-side rectangles, it's going to be a rectangle. And notice all those rectangles have the same height, which is the same height as the prism itself. That rectangle is going to be made up of many of those lateral faces, kind of all joined end to end there. So the next thing we're being asked to do is to write an expression for the length of the base of that rectangle. And that base that you see there, hopefully, is A plus B plus C. So we're unfolding all the sides of the triangle for that base length. Part D, how is the base of the rectangle related to the perimeter of the base of the prism? Well, the perimeter is the same thing as all three sides of the triangular base of the prism, so it's the same thing. Part E, let's find the lateral area, which again is that rectangle, in terms of, they say, H, A, B, and C. So the height times the length of the base of that rectangle, which we know is A plus B plus C. And then the final thing we're going to be asked to do there is write a formula for L in terms of P. So if we know A plus B plus C is P, perimeter, then the lateral area is simply equal to perimeter times height. So now at the top of the next page, we're going to say let B, remember that's the area of the base of the prism. We're going to write a formula for the entire surface area of the prism in terms of capital B, the area of the base, and L. So we know the wraparound pieces, the lateral area, plus the two parallel bases areas, because we need to have one on the top and one on the bottom, and that's going to be my surface area formula. It's a very kind of skeleton formula for surface area, so when we're talking about a prism, that's going to be the perimeter times the height, or lateral area, plus 2 times whatever the base shape is. So now we're going to go down to our formula here. We see in your box, you've got them restated. I'm going to put a big old star next to this, exclamation point, highlight, whatever it is you need to do. These are important formulas for you to know. Just like on the volume quiz, you're going to have these formulas given to you to match up with the correct shape. And just so you know, this formula for a prism works for any prism. So There are lots of prisms that we could use, but this P times H plus 2B formula works for all of them. So we're going to start with a rectangular prism. We've got a gift box here that we want to wrap up, because remember that's the application of surface area, is wrapping it around. So we're going to go ahead and find all of the lateral areas first, and you saw me highlight just the sides that are perpendicular to the top and the bottom. So we're going to start by stating our lateral area formula and then putting in our perimeter, which is 2 times 8 plus 2 times 6. So we've got 28 times 12, which is the height. And we're going to multiply that and we get 336 centimeters squared. So that's just the sides, you guys. Now we want to find the total surface area. And to do that, we're going to take the lateral area that we just came up with, which remember is just the sides, and plug that into surface area equals lateral area plus the two bases. Substitute the value we just came up with, 336, and then plug in the area of the two bases. Now the base shapes are rectangles, so base times height there of 6 times 8 twice added in gives me 432 centimeters squared. Okay, so now we're going to go on to the one where we're filling in as we go. We've got the length first of the hypotenuse that we still need to find. So remember, C is the hypotenuse, is the longest side that's missing there. So we're going to fill in 10 and 24 into Pythagorean theorem. 100 plus 576 is going to be 676. And then the square root of that gives me 26 for the missing side. Now that's important because remember, for lateral area, I have to know the whole perimeter. So if I add up A plus B plus C, I'm going to get 60. So 60 gets substituted in for perimeter. The height of the prism is 20. Multiplying that out, I should get 1,200 inches squared. Notice all of these surface areas have had square units. Last step is to find the total surface area. We're going to take that lateral area I just found and then add in the two bases. Remember, these bases have a triangular shape, so we need to have 1/2 times the area of the base of the triangle face, which we could say is 10, times the height of the triangle face is 24. I'm just doing a little bit of simplification off to the side there. That's 1,200, that should say, plus half of 240, sorry, and we get our final answer. Okay, so now we're at the Q part of our whisk, okay, which is your on your own problems. These are the problems that you're going to need to check and make sure that you're understanding. And I'm highlighting this spot down at the bottom of the workspace because you can see on your version of your whisk, I've already given you the answers for these. So at this point, I just want you to pause the video, do these problems out, and make sure you get the right answer. Don't go on to the next part, please, unless you know you are understanding this idea, but let's keep going here. So next we're going to be finding the surface area for a cylinder. And I hope you can see, just like we saw in the first video, if we kind of slit the rectangle open and unrolled the label part, if you will, we've got a big rectangle whose dimensions are the height times the circumference of that circle. And then the top and the bottom faces are circles, so we have 2 pi r h for the area of the rectangle plus 2 pi r squared for the two areas of the circle. So make sure that you take note of these formulas, okay? Moving on to the next page, we've got an example done out for us, example 2a here. We're going to find the lateral area. And that lateral area, remember, is just the rectangle label, so 2 pi RH. I'm going to substitute what we know. We know the radius is 3. We know the height is 9. So substituting all three of those values in there, 2 pi RH, 54 pi. And I think it makes sense probably to keep things in terms of pi like we've done in the past, just till the very last step. So now we're going to find the surface area by taking that 54 pi that we just came up with and then plugging our radius into the area of the top and bottom circles, or 2 pi r squared. There's a bit of a typo here, you guys. Should be 54 pi and then plus 9 times 2 pi, 18 pi. That r right there actually should be a pi symbol. But when you add those two together, we're going to get 72 pi centimeters squared. At this point, and only at this point, we should get a calculator out and take our pi key into consideration there, and then get our answer. So I scrolled down a little too far here, but you can see what we're looking at is the same process. There we go. So we've got our lateral area formula. We know our diameter this time. So do make sure that you cut that in half to get the radius. The radius is going to be 2.5. So 2 pi 2.5 times the height of the cylinder, which is 2. And then multiply that all out, we should get 10 pi inches squared. But remember, we still need to add in the top and the bottom to get the total surface area. So stick in your 10 pi for the lateral area, and then add in the two circles. And again, there's a bit of a typo here with the r. That should be a pi symbol. So we've got 2 pi times the radius, which we know is 2.5 all squared. That's 22.5 pi altogether. Now we're going to stick that into our calculator. And for this problem, the paper was the lateral area, so that's the 10 pi or 31.4. And for this problem, the aluminum for the whole can is going to be 70.7. So it says, in these problems, why is it best to round only in the final step of the solution? Guys, the answer is that it's more accurate. It's always been more accurate to wait to the very end to include any approximations. So if possible, leave pi out until the very last step. If you've ever lost any points for accuracy on any quizzes in the past, keep that in mind. All right, we're at our Q part of our whisk again. This is your turn. Again, highlighted in the bottom on your copy there are the answers you should get for each one. So do pause the video at this point and do those two on your own problems. Make sure you get the correct answers that are listed. Okay, and the last part of this video is just going to take us to a composite figure. This can be a little tricky, so You really need to make sure as you're reading through and looking carefully at these diagrams that as you're doing your work out, you make sure that you organize your work. Because if you lose track of, oh, I don't know what the lateral area was of this, I don't know what the surface area was of this, you're really going to kick yourself. Okay, so organization in your work is key. If the space given in the whisk is not enough, then attach some other pieces of paper. But in this case, we are basically looking for painting the entire surface and then taking the cylinder out of the pyramid. But remember that for the surface area, we're like painting the entire outside plus kind of sticking a paintbrush down through that cylindrical hole and making sure that we cover that too. That's what they're talking about for surface area. So the first step is we're just going to find the surface area of the right rectangular prism. So the perimeter is 80 of that 24, 24, 16, and 16 is 80, times the height is 20, and then plus the two top and bottom faces of that prism is the 2 times 24 plus 16. So we got that part. That's just the prism. Now we're going to remove the cylinder from the prism, and we're going to start by finding the lateral area of the cylinder. So we've got our 2 pi RH formula. Our radius of that cylinder is 4, and our height of that cylinder is 20. Then we're going to add in the base area formula, which we know is pi r squared, and find one of those base areas. Then we're going to find the composite figure. So this is the part that gets a little bit tricky, so try to pay attention. First, it's the sum of the areas of all the surfaces, because we'd be painting the entire prism, and then we'd also be painting the lateral area on the inside, so this is just a reminder to make sure you're painting it inside and out, okay? We're taking the prism surface area, then we're adding in the cylinder lateral area, but then we need to subtract out the cylinder base areas because there's a hole there. So make sure that you do that, or else you'll count 2 more pieces than you really should be in the surface area of this figure. So that subtraction is really key to pay attention to. And as we put in those pieces, again, notice things are in terms of pi until the very last step. We get 2,770.1 feet squared. Okay, the next example is one we're filling in on our own here. Well, together, but one that is not done out for you in the textbook. Start by taking the perimeter of that base shape, which is going to be 18 plus 8, or 26, times the height of the prism, which we know is 5. Then we're going to add in the 2 faces, top and bottom faces of the prism, which are 9 by 4 rectangles. Simplifying that out, we have 130 for the first piece plus 72, and so 202 centimeters squared. Now we're going to find the surface area of the whole cylinder. First, the lateral area is your circumference, 2 pi r, times the height. Our radius is 2, so 2 pi times 2 times the height of the cylinder, which we're told is 3. And simplifying that out, we get 12 pi centimeters squared. Again, that's just the lateral area. To find the whole surface area of the cylinder, we're going to do 12 pi, which is the lateral area, plus 2 pi times the radius, which again is 2 squared, or 20 pi for the entire surface area of the cylinder. And again, now comes the part where we figure out what we need to add, what we need to subtract here. The surface area is the sum of all the areas of the surfaces on the exterior of the figure. We're going to take the prism, which is stacked, on top of that is stacked the cylinder. So if we put those two surface areas together, I hope that you can see the covered up part is the area of one cylinder base twice. Once for the bottom of the cylinder, and then once for what it's covering up on top of the prism. So 202 for the prism surface area plus 20 pi for the cylinder surface area minus 2 times the area of one cylinder base. And we get 239.7 centimeters squared. Here are your on your own problems again. Make sure that you check on the answers for each of these at the bottom of your screen. And again, go ahead and pause and do those two problems. And then the last thing I just want to say to you guys here is don't worry. We will definitely probably need to check in about these last on your own problems. They can be a little tricky. Again, the key is organizing your work, and we'll figure it out. I'll see you tomorrow.